This is a custom 2D engine running procedural dungeons, flocking AI boids, dynamic minimaps, and an organic smooth gliding snake. But getting here was an absolute nightmare. The architecture was complete disaster. Just look at this old point class. The dungeon paths kept sealing themselves off, and the snake code had a mind of its own. Here is exactly how I built it, how it broke, and how I fixed the physics, the rendering, and the collision systems. It started simple. Just basic squares moving around, eating bird AI enemies. It worked, but it was honestly pretty boring. Then I stumbled across a video breaking down procedural animation for snakes and fish. It completely changed how I thought about movement and procedural animation, and I immediately went to rebuild the game from scratch. This was the first prototype. The movement was there, but wrapping a clean, responsive skin around those dynamic joints was incredibly tough. After a lot of trial and error, architectural refactoring, and bouncing ideas off an LLM, I finally got the rendering to match the physics, and seeing it move like this for the first time was incredibly satisfying. Alright, so the snake was moving great, but it was just floating in empty space. It needed a world. Right around then, I saw a video breaking down dungeon generation and got caught between cellular automata and binary space partitioning. I picked BSP because I figured it would be easy, but it wasn't. My first attempt was just copying a tutorial step by step to see how the math worked. I rebuilt the whole algorithm completely from scratch a second time to actually learn it. By third iteration, I scaled the whole thing up, threw in an active collision system, and added a camera tracking to follow a basic player box around. Now on screen this worked perfectly. The tracking map did exactly what it was supposed to do. But under the hood, complete disaster. The map logic, the mouse listeners, the player movement, the camera offset were all hard-coded and jammed into exact same classes. It was working, sure, but the code was tightly couple-trapped. Trying to add anything else to this monolith was going to be a nightmare. Which brought me to the actual goal, getting the snake game working inside these rooms. Step 1 was putting the snake back in and building camera tracking specially for it. The first tracking method I came up with was honestly pretty rough and completely coupled, though I did go back and fix it later. But the real wall hit when I tried spawning the snake segments cleanly inside the first room. The positioning math was getting annoying, so I ended up asking an LLM for help. Honestly, looking back, it wasn't even that hard. I could have solved it myself if I just sat there and tried a little harder. But I wanted to get it done quickly. But now I had a massive, unmaintainable monolith handling procedural generation, rendering, physics, and AI all in one place. It was time to refactor. So I started digging into how professional game engines handle scaling without turning into spaghetti code. And that's when I discovered ECS. ECS stands for Entity Component System Architecture. Honestly, it was difficult to understand it the first time, but after breaking my head over it a few hours, the pieces clicked. It splits everything into 3 dead simple parts. The first part is entities. Entities are just blank IDs with zero data. The second part is components. Components are pure data containers with zero logic. And the third part is systems. Systems are the actual code blocks that scan for matching components and do the heavy lifting. Once I had that down, it was time to drop the hammer. I didn't want to patch my old code. I decided to open a completely fresh repo and build a brand new engine from scratch, putting together every single thing I learned so far. The procedural snake, the BSP dungeon, the ECS architecture, and a flocking boid AI simulation. But starting fresh didn't mean smooth sailing. The first massive wall I hit was the room collision. I chose to use SAT. SAT stands for Separating Axis Theorem. Mostly because I wanted the challenge of learning the math, but the logic backfired hard. My collision system was working in a way where it was treating the entire room as a solid block and locking the player out entirely. To fix it, I broke the rooms down, generating 4 individual wall entities per room so the inside remained completely walkable. I even bounced a few architectural ideas off Gemini to make sure I wasn't overcomplicating the entity layout. Right after that, the hallways gave me a massive headache. The BSP tree was splitting the canvas fine, but the actual connecting corridors kept rendering completely blocked off, turning my open dungeon into a series of isolated escape rooms. This part generally started melting my brain, so I leaned on AI to help me debug the corridor carving logic. But once those paths finally cleared up, I had an actual functioning world. With the world built, it was time to spawn the star of the show. I wanted every single snake segment to be its own independent entity so that individual body parts could actually collide with the dungeon walls. But the moment I loaded it in, the snake literally gained a mind of its own and started moving across the canvas. It turned out my physics math was fighting itself. The distant constraints were aggressively pulling the body segment toward the head, while the wall collision system was violently pushing them away. The obvious fix was to just disable collision between the snake's own segments, except my early architecture wouldn't let me. I didn't have a dedicated collision component yet. Instead, my physics and rendering components were pulling double duty handling collision. There was no clean way to tell an entity what it should hit and what it should ignore. So, time for yet another refactor. I pulled collisions out into their own isolated component. Now the collision system only cares about entities carrying this specific component, and the component itself holds a clean mask defining exactly what to hit and what to ignore. And the problem was solved. Next up, the bird simulation. I spun up 2 new systems, one to handle spawning the birds safely inside the room boundaries and another to calculate the alignment, cohesion and separation forces that make them flock together. Right now, they just look like a swarm of aggressive boxes, but they brought a massive boss level problem with them: performance. My flocking logic was running at a brutal O of n square time complexity. Every single bird had to check the position and velocity of every other bird on the map. If I spawned 1000 birds, the engine was forced to run 1,000,000 checks every single frame. The browser instantly choked. The solution was obvious. A bird on the far left side of the map shouldn't care about a bird on the far right. It only needs to check its immediate neighbors. To pull this off, I built a spatial hashing system. Instead of checking every entity against everything else, the engine maps the entire game world into a grid of buckets based on coordinate position. When a bird updates, it hashes its coordinates, finds its bucket, and only runs calculation against the handful of birds sharing that exact same space. This completely smashed the bottleneck. I dropped from a brutal O of n square time complexity to O of n linear time complexity for local checks. The frame rate shot back up, the browser stopped choking, and suddenly I had many entities flocking flawlessly in real time. Even with spatial hashing saving the birds, the engine still had a breaking point. If I generated too many rooms or dropped in too many entities, the frame rate would start to tank again. And the culprit was simple. The engine was wasting massive amounts of processing power, drawing rooms, running physics, and calculating collisions for things completely off screen. So I introduced camera culling. I wrote a fast proximity check that only activates rendering for entities within a 300 pixel radius of the player. If you can't see it, the engine doesn't draw it. It worked so well that I pushed the trick even further, applying the same culling logic directly to the physics and collision system. If an entity is too far away from the player, its logic freezes entirely until you get close. This was the ultimate game changer. Before this refactor, I could only risk spawning 40 to 50 birds in about 60% of the rooms before the browser would lag out. Now I can confidently drop 100 birds into every single room on the map without a single stutter. With the performance finally locked down, it was time for the final touch, replacing those placeholder boxes with some actual style. I redesigned the birds and turned them into a swarm of rats for the snake to hunt. And that is exactly how I built this custom 2D engine from scratch. It started as a basic square snake on a blank canvas, survived a massive architectural crisis, and pushed web physics to its absolute limit. Rebuilding it with custom ECS was a brutal learning curve, but solving these kinds of engineering puzzles is exactly why I love development. The project is finally exactly where I wanted it to be. Thanks for watching, and I'll see you in the next build.